at letter E here, it says atoms bond to obtain stable noble gas electron configurations. So what that means is that each of these atoms is going to try to look like a particular noble gas. I think that the easiest way to figure out which noble gas it's trying to look like is by counting up the electrons. So whichever electron configuration it's trying to replicate is the noble gas it's trying to be. So for example, if we take a sodium ion's electron configuration and look at who it's trying to resemble when it gains or loses electrons to become stable, if I look at sodium, we said that sodium would lose an electron. And normally, sodium has 11 electrons, but then it loses one to have 10 electrons. After it loses that electron and it has 10, the noble gas that it looks like is the element that has 10 electrons, which would be atomic number 10, neon. So the noble gas it's trying to look like is neon. And then that same process can be done for all of the other elements listed on here. So if I have lithium, lithium normally has 3 electrons, but it also wants to lose 1. So when it loses 1, it has 2 electrons. When lithium has 2 electrons, when it loses to have 2 electrons, the element that has 2 electrons is helium, which is one of my noble gases. That's who lithium is trying to look like. So helium for lithium. For nitrogen, it's going to look like the element that has 10 electrons when it gains 3. So the element that has 10 electrons we already found was neon. And then finally the last one is sulfur. Sulfur is going to end up looking like the element that has 18 electrons, meaning atomic number 18. And atomic number 18 is argon. So it's no coincidence that every time we did this, it's gaining and losing electrons until it reaches the noble gas electron configuration. And then letter F says electron dot structures, which are Lewis diagrams, depict valence electrons as dots. We did this briefly, I think, in our atomic structure unit, but we'll do it again. Your valence electrons are your outer S and P sublevels. They're placed one at a time. On the 4 sides of the symbol, and then they are paired until all are used.